Hey, welcome back to the course, and in this lecture let's understand about the volatile qualifier in C. Okay, so its usage is really important in embedded systems, and let's learn why should we care about this qualifier. The better way to understand this keyword is directly experimenting on the hardware, okay, to see what happens if we use volatile. Let's compare that with what happens if we don't use volatile qualifier by just writing one simple application. Okay, great. So now I would like to directly take you into Keel IDE. Okay, the same experiment you can do it on Eclipse also, and I'm ready with my project. I just added my main.c. Now let's get started. Now let me write my main program. Let's compile this. Yes, it works. Okay, now what I want to do is I want to read some data from the SRAM memory location, okay, or RAM memory location. So first I will define that address here. Okay, so I'll just hash define it using my macro. I'll just say SRAM address 1 or something. Okay, and the address from which I'm going to read is, let's say, 0000004. Okay, since it's an unsigned address, just write U. Okay, great, fine. So this is the address from which I want to read some data. That's it. Okay, so now in the program what I do is I just write one variable. Okay, let's say variable or value is equal to 0, and now what I do is I go into a while loop here. What I do is I continuously read this address, okay, I mean the value which is there in this address into this value. So how to do that? First you have to define one pointer, right? Okay, so let me do that. uint32 underscore t pointer p. Okay, so let's say this is a pointer, and this pointer has to be linked with this address, right? Great, so let me do that. So p is equal to, so I'll just do this. So will this give any error? So if I compile this, what compiler says is value of type unsigned int. Okay, so this is a value. So how do you convert it to pointer? Just typecast into pointer uint32t star. Okay, so now this value is now converted into pointer of this data type, that is unsigned int, and now we are storing that address into a pointer whose type is unsigned int. Okay, so that means this is now a valid statement, so the compiler is now happy. Okay, great. So now, so instead of doing this in 2 lines, you can do it in only 1 line. Okay, so I'll just do it like this. Great. I have to read this address continuously. Okay, so how do you read? So I just make this value is equal to star p. Then what I do is if value, okay, then I break. So if value is non-zero, then I break this loop. So that means I'll come somewhere here, and here I will again trap. Okay, so very trivial application, but okay, the thing we are going to learn from this application is huge. Okay, because see here what happens if I read some value that is non-zero value from this address, then this turns out to be true, and I break and I come here, isn't it? So if this value is 0 always, then I will trap in the first while loop, right? Great. So now what we'll do is now we'll test this. Okay, so now let me just recompile this, and I'll just download this, and I'll just put my breakpoint here as well as here, and let me go into my debug mode. Okay, now I just run. Okay, so now I am here, and I remove this breakpoint, and I'm observing that address here, okay, 2004, and you can see the content of 2004 is, I mean, this address is 0000, so that's why I will always hang in the first while loop, isn't it? Because this is 0. Okay, so let's check that. You can see here I'm always hanging and the second breakpoint is not yet hit. Correct? Great. So now let's stop the code execution. Okay, now the code execution is stopped. Now what I do is I write some data here. Let's say 45. Okay, I wrote some data here. Okay, now if I hit run, what happens? Now this value will have this value now. Okay, that's why I break this loop and I come here, isn't it? So let's do that. Yes, that's true. Okay, I came here because this is evaluated to be true. So I came here and everything is working as expected. Okay, great. So this code is working fine. All right, so now what I do is I just copy the assembly code generated for these C code. Okay, so here it is in the D-assembly, it is showing, okay, right from the beginning, that is this line, right? So I just copy all this code, okay, until here, right, while one loop, this one, right? So until while one loop, the last while one loop, that is until here, because while one is the last instruction, right? So that's why I just copy till here. So I'll just copy this, okay, and I'll go to my notepad and I'll just paste this. Okay, so this is this assembly code. Now let's come out of the debugging state. So now let's change the compiler optimization level of this code. Okay, so for that, go to your options for target, go to C and C++, and currently it was running at level 0 optimization. So that means the code we generated is for level 0, okay, optimization. So now we will copy the same code for level 3 optimization. Okay, great. So now I'll just select 3 here and I'll click OK, and I'll just click rebuild the code. Okay, I will just rebuild the code and I will just again download the code, and I'll just go into my debugging mode. And now what I do is, again, I will just copy the code generated. Okay, so right from here, okay, until the last while one loop, that is this much, right? I'll just copy that and I'll just paste here. Okay, so this is a code generated at optimization level 0, and this is a code generated at optimization level 3. And look at the code size when we change the optimize level to 3. The code is much smaller compared to code we got in level 0. Okay, so that means the compiler indeed optimized our code, right, to save the precious memory, that is flash memory. Okay, great. So we should thank our compiler for that. Okay, it indeed saved some space for us, but that's a problem. Now the same code will not behave as it behaved in the optimization level 0. So let's check. Let's go into debugging mode once again, and now let me keep a breakpoint here, and also let me keep a breakpoint here, and let's check. Now let me remove this breakpoint and run. Since it is reading 0, okay, so everything is working fine. Now I'll just stop the code and I'll just change the value to something else. Okay, and now what is expected? Now this should be evaluated, right? Now the value is no longer 0 here, so that's why it should come here, right? So as we saw in the level 0 optimization case, right? So but interestingly, you can see here when I hit run, it won't come to this while one loop. Okay, you can see here it is still trapping in the first while one loop, even though we changed the value of this memory location. Okay, it is not at all hitting this breakpoint. That means the code is not working when you change the optimization level. Okay, so now how do you fix this? And the answer is you can fix this by using the volatile keyword that I will show you in the next lecture.